Hello, everyone. Welcome to our webinar today. This webinar is being presented by Clean Energy Group, and the topic is battery energy storage systems in Massachusetts, benefits and safety considerations. The date today is November 18th, 2025, and we have an excellent panel of guest speakers here with us today. But before I pass it over to them, I'd like to go over a few webinar logistics. Your webcam is disabled. If you would like to submit questions and comments, you can do so via the chat function. Um, we'll be saving about hopefully up to half an hour after the presentation to address audience questions. So if you think of a question during the webinar, just type it in the chat and we can get to it during the Q&A at the end. We will also be accepting questions verbally during the Q&A. So if you would like to ask a question verbally, you can do so by raising your hand and then you'll be able to unmute once you're called on. Automated captions are also available. Speakers' bios will be made available in the chat shortly. And finally, this webinar is being recorded. We will email you a webinar recording within 48 hours, and it will also be posted on Clean Energy Group's website at cleanegroup.org/webinars. We encourage you to provide feedback for us via the post-webinar survey that will pop up after the webinar or via email. And with that, I'd like to pass it over to our host for today, my colleague, Abby Ramanan.
Great, thanks, Serene, and thanks everyone for joining us this evening. This webinar is being hosted by Clean Energy Group. We're a national nonprofit working to accelerate a just transition to affordable, reliable, and clean energy for all through a variety of technical and policy solutions. Next slide, please. And this webinar in particular is being hosted through our Phase Out Peakers initiative, which is a first of its kind initiative to replace fossil fuel peaker power plants with clean alternatives, including things like energy storage and renewable energy generation in environmental justice communities. We have a variety of awesome speakers for you today who will be covering how battery storage can be used in particular to replace fossil fuel peaker power plants and how they can be sited safely for communities. So we'll kick things off with Maria Bajani, who's co-executive director at Slingshot. Then we'll hear from Rosemary Wessel, who is part of the Berkshire Environmental Action Team, followed by Brittany Ebeling, also with BEAT, and then my colleague Ava Morgan, and then you'll hear from me at the end. We'll cover a variety of topics about battery storage, including both the benefits of it, as well as some certain safety considerations. And as Doreen mentioned, we're hoping to save a lot of time towards the end for Q&A with you all. So if you do think of a question, feel free to either drop it into the chat just when you think of it, or save it to the end, and you can either put it in the chat or just raise your hand and we will allow you to unmute and you can ask it verbally. So with that, I will hand it over to Marie.
Thanks, Abby. Welcome, everyone. Looking forward to chatting today about battery energy storage systems. So if we can go to the next slide, I wanted to first give you a little bit more background on the Massachusetts Clean Peak Coalition, which is the set of our organizations presenting this webinar. And as you can see on the slide, our vision as a coalition is a community-led transition of peaker plants to 100% clean and renewable energy that will safeguard the health of all residents, especially those most impacted by the health, economic, and racial injustices of fossil fuel infrastructure across the entire state of Massachusetts. And we bring organizing expertise, technical expertise, and lots of relationships with various officials to those transitions and supporting communities in seeing what kind of alternatives they want to pursue. So next slide. I want to first talk a little bit about replacing peaker plants. So in case anyone is less familiar with that terminology, peaking power plants, or peakers as we call them, are power plants that run for just a few hours of time during peak demand, often the hottest and coldest days of the year. And they are the most polluting per unit of energy produced because they get ramped up and then ramped down when they're just turned on for a few hours. And that process of getting ready to be fully operational, they're not producing energy, but they're emitting pollution during that time. And also our peaker plants on the grid currently tend to be a lot of our oldest infrastructure and therefore a lot of the dirtiest power plants. And so they often run, as I said, for just a few hours at a time, which makes them easier to replace than a power plant that's running 24/7. Because with battery storage and technology like that, we can easily cover a few hour time period. These peaker plants are often located in environmental justice communities, communities of color, low-income communities that have been disproportionately impacted by the harmful legacy of our energy system. And so it's really important to reduce pollution from these facilities in particular to make sure that we're supporting these communities and having a healthier future. And these facilities are also paid to always be ready 24/7, 365 in case we need to call on them. And that money honestly can be put to better use with other technologies like battery systems that can serve more uses kind of along the way and provide more grid services. So it's a better investment to look at alternatives instead of putting tens of millions of dollars into each peaker plant that we have, on our grid for those few hours when we need to call on them. Next slide. And then a little bit of federal and state context I want to share here. The recent big energy-related bill, the One Big Beautiful Bill Act from the Trump administration, repealed a lot of tax credits that had been in place and incentives for wind and solar, other forms of renewable energy. And in addition to that, the federal administration is continuing to pile on roadblocks for the clean energy transition. One thing that has remained largely untouched for now is energy storage. And so it's possible, we're already seeing a lot of energy storage pop up, and it's possible that more clean energy developers will head in that direction because they're being, slowed down in from other perspectives, and storage is something that they can continue to pursue. And in addition to that, Massachusetts, the Department of Energy Resources will be investing $50 million to catalyze energy storage deployment to help meet state climate goals. And this project is called the AMP. It's being kind of launched very soon, or kind of in the process of being launched. And so we expect to see more energy storage deployment across the state. And that's part of the reason we wanted to have this webinar to really dig into what that can look like, what that means for us here in Massachusetts. So next slide. That leads me to why this webinar, why this topic right now. As I mentioned, battery storage is proliferating quickly. A lot of communities across the state have seen proposals come to their neighborhood, and they're struggling to keep up with what that means in terms of safety, in terms of environmental context, in terms of economic context, et cetera. So we thought it'd be good to have this conversation to provide folks an opportunity to learn more and ask questions. The technology is also evolving rapidly, and there's a lot of information out there, and it can be hard to digest, what's true, what's not, what's the stuff I have to pay attention to, what's stuff that, can be kind of in the periphery. So we're hoping to really distill that into the top line pieces. And we also want to acknowledge that incidents involving batteries have sparked safety concerns. So we want to get into what are the actual safety considerations with battery storage, especially as the technology continues to improve and we find batteries, being proposed in more and more places. And also, we know that storage is an essential part of the clean energy equation. As we move towards more wind and solar, we need battery storage paired with those sources of energy to have our grid run effectively and reliably. And so we need to get storage right. We need to have these kinds of conversations so that we can embark in this direction and make sure that we are continuing to unlock the potential of this transition and move towards clean, renewable, affordable, and safe energy for our communities. So with that, I'm going to pass it off to Rose, I believe.
Hi, yes, I'm Rosemary Wessel from Berkshire Environmental Action Team. Thank you, Murray. So what is BESS? You see that acronym a lot, especially as people are proposing projects. BESS stands for Battery Energy Storage System. It's a very simple acronym, very simple description. Battery energy storage systems are made up of individual battery cells that are combined to make modules. Those modules are then stacked onto racks, very similar to server farms where you have a lot of computer servers stacked up on a rack. a very similar system, and then those are combined into containers, usually shipping containers. BESS can be charged by power generating systems like power plants, photovoltaic arrays, wind turbines, or through just power from the grid. Next slide, please. Battery energy storage can increase the reliability and flexibility of the grid by having power stored and ready to go. It can save money for electricity customers, especially if it gets into peak shaving. The less we need to use peaker power plants, the most expensive ones on the grid, the cheaper our energy will get. It reduces local air pollution to use battery instead of power plants nearby, and it reduces greenhouse gas emissions. Next slide. So these battery energy storage systems can charge at times when electricity demand is low and renewable energy is available, and then it discharges that energy when demand spikes, reducing reliance on the peaker plants. It's a crucial part to integrate intermittent renewable resources into the grid. Next, please. So this was a grid demand day that I grabbed off of ISO New England's website. This is what the grid actually did on August 18th this past summer. And it's a very common form that the grid demand takes. You can see early in the morning, grid demand drops quite a bit. And then it starts to rise around as the sun comes up. People are getting up, they're getting ready for work. Businesses are starting up, they start using power. And then in the middle of the day, it drops tremendously. This is called the duck curve because it has that kind of curve like the back of a duck. That happens when all the solar comes online. It comes onto the grid and meets the majority of the demand, or even sometimes exceeding demand. So during that time, there's a lot more power available than is being used. Then during the evening, when the sun starts to go down, it looks like demand goes up, but that's mostly because the solar is coming off of the grid while that demand from the day still exists. And then when people come home in the evening, they turn on air conditioners, especially on summer nights, turn on air conditioners. They might run their washing machine and their dishwasher, and demand starts to rise. And if there's a lot of that going on when it's very hot weather, that's when we get into peak demand and extra power plants are brought on to meet that demand. Next slide. So the great thing about battery storage is you can store all of that extra energy that's coming on the grid because of solar. So during peak production, you're charging up that BSS. And then at night, when the grid starts to peak and when solar demand or solar production drops, that's when you can withdraw energy from the batteries to supply that peak demand. So that entire top peak, that green peak, could be shaved off with enough battery storage capacity. Next, please. So it saves money for electricity customers. During times of peak demand, electricity is the most polluting and most expensive. Part of this is because of the way ISO New England structures their markets. They pay more as more demand goes up. So as they exhaust the cheaper electric sources and they still need more electricity, they start paying the more and more expensive ones as demand rises. Because BSS can discharge energy at these peak times, it can lower electric rates. It can also prevent costly upgrades to transmission and distribution systems because it can go right into the existing systems, and it can improve reliability. It reduces or avoids brownouts and blackouts. Next slide, please. So batteries and small-scale solar actually saved New England customers $20 million in just a few days during the heat wave this past June. This was an extensive heat wave, and we actually saw a peaker plant locally run for far more hours than it usually does. And with more BSS on the system, that would happen less and less. And BSS provides important grid services. Black start is when there's a power outage and the entire system needs to start up again. There can be a lot of inertia in starting it up. And if you're waiting for regular combustion type power plants to start up, it takes them a while to ramp up to the degree of power they need to supply. With batteries, that power is available instantly. It cuts out the ramp up time from thermal power plants, which can take hours, as opposed to the seconds for battery storage. And it also offers grid balancing. It has really quick response times. So if there's an imbalance in power in the grid, they can be brought on in an instant to help supply that. They also provide frequency regulation. If the grid doesn't operate at around 60 hertz all the time, that can take down the system. And they help provide that kind of balancing as well with frequency regulation. So they're actually more stable than using the existing fleet of combustion power plants that we have. Next, please. It also reduces air pollution. They have 0 point source emissions, meaning that they don't release anything while they're working. So if they're charged with electricity produced through renewable, they're completely zero emission sources of power. Even when they're charged by a grid mix, batteries can restore the amount of local air pollution, especially when replacing fossil fuel power plants. And we saw this in West Springfield. It was one of the most polluting peaker power plants in the state. And we asked them, could you consider, switching to battery storage, which they're in the process of, but they stopped fossil fuel production in 2022, and the air quality has gotten better in the Springfield area. There may be other factors, but I'm sure that's a part of it. And we look forward to seeing that turn to battery storage very soon. With that, I'd like to turn it over to BEAT's Executive Director, Brittany Ebeling.
Thanks, Rose. So Rose gave an overview of what is meant by the term BESS, but I want to just note that there's a distinguishing feature between just ESS, which refers to the multiple types of technologies capable of storing energy. But of course, in this context, we're going to be focusing just on battery systems capable of storing electricity. You can also see here listed some other types of battery storage, or some other types of storage systems, which include systems that use mechanical or thermal technology processes. And I'll just note that the most common and commercially available battery storage chemistry is lithium ion. Next slide, please. Batteries may rely on a range of different chemistries, including those that use non-toxic materials. And there's a wide variety, but it's exciting to see the development of new technologies coming onto the market. But again, the most common type of battery technology for BESS is lithium-ion batteries. Next slide, please. There's a range of considerations involved in establishing what type of battery chemistries are used at a given site, including taking account of variables like the duration of battery storage, desired energy density at a site given its size constraints, cost, and safety considerations. Rose described how battery technology can smooth the peak by providing energy during moments when the grid requires it. And some batteries are long duration, meaning that they can provide discharge services even over very extended periods of time over multiple days, for example, while other types of batteries may be shorter duration and able to be deployed for just a few hours at a time. Depending on the battery chemistry, best practices for spacing and density of megawatt hours per acre of land differ, but in general, longer duration batteries have a lower energy density. Other considerations for optimal design of BESS include cost and safety considerations, which will be discussed in greater detail later in the presentation. Next slide, please. This table gives an overview of how duration, commercial availability, environmental impact, fire risk, and energy density considerations differ across battery technologies. Most large-scale installations are lithium iron phosphate batteries, which, while not allowing for as much energy density as lithium-ion NMC batteries, they do have a lower fire risk, long lifespan, and still, in comparison to other battery chemistries, do allow for a high energy density. Next slide. As a clean energy technology, batteries have a significant role to play in achieving our state's decarbonization targets and clean energy transition, but there are siting considerations that make some projects more ideal than others. The best place to build BESS is near existing electrical infrastructure like substations, which is exactly what makes peakers ideal locations for transitioning to battery storage sites. Rather than disturbing new land, batteries at a site that has previously been used for fossil fuel-based energy production can utilize grid infrastructure or grid interconnection services that already exist. Peakers often have interconnection capacity that's unused for most of the year, meaning that these sites also have the potential to provide more energy to the grid in the form of batteries without requiring an expensive additional interconnection study. Next slide. BESS installations require siting that enables appropriate ground composition for the weight of the batteries and requires proper road access. So ideally locating them on brownfield sites provides clean energy services to these otherwise underutilized properties. Rose mentioned the site in West Springfield where our coalition worked with the company Cogentrix to decommission its peaking power plant at that site, where they're now planning to bring online solar and battery storage, an example that highlights how plants of this sort can make the transition where grid interconnection infrastructure already exists. Last slide, please. So lastly, here's an example of another solar and battery storage facility in the state. We've received some questions about if BESS can be placed on landfills. And as I mentioned, battery weight is a limitation in siting. However, configurations like this one show how co-locating batteries with solar, where the solar panels are placed on a landfill site, can make that type of build out possible. And with that, I will pass on to Ava from Clean Energy Group.
Hi, everyone. I'm going to talk a little bit about battery energy storage system safety. As Murray mentioned, as deployment increases, there are, some increasing concerns from communities, especially as there have been some high-profile fires making the news. And so I'll just start off by talking about one of those high-profile fires that happened earlier this year. Next slide, please. So in Monterey County in January of this year, there was the Moss Landing fire at a battery facility. It burned for multiple days and reignited weeks after the initial flames and did lead to an evacuation of the surrounding residents. This making the news has led to a lot of conversations around safety concerns, and these conversations are extremely important to have. This fire was a very unique fire. Next slide, please. And, for a handful of reasons, it was an anomaly. And so the age of the battery, helped to facilitate some of the thermal runaway. This was approved and constructed in 2019, and it was built before a lot of the widespread adoption of specific certifications and standards that improve battery safety, and we'll get into those a little bit later in the presentation. The specific battery chemistry used was lithium NMC, as Brittany mentioned. It is more prone to thermal runaway than the more widely used lithium iron phosphate that's used right now. And then one of the other key components that made this fire very unique was that it was
the batteries, the 300 megawatt battery system, was installed in a repurposed building, a very old building from the 50s. Now battery systems are installed in containers, typically outside, or in buildings purposefully built for those battery systems. Next slide, please. And so these conversations are very important to have around battery safety. And one important statistic too is that since 2018, the failure rate per gigawatt of battery energy storage system has dropped by 97%. These technologies are being innovated quite rapidly and being deployed. And so we do see that major drop in battery failure rate and incidents. Another important statistic is there have been no reported deaths from lithium-ion battery storage fires in the US. And we know that, just recently, California announced that they are nearing 17 gigawatts of battery energy storage deployment. And, a lot of states have goals of introducing more battery storage systems to help with that integration of renewables. Next slide, please. So there are quite a few certifications that batteries can go through, specifically lithium ion, to test all of the cells and modules and racks. And, they even tested on a whole system level and how they respond to mechanical shock and temperature extremes and electrical misuse. So if a battery installation is being proposed, it's important to, make sure that these batteries are going through these specific certifications. They also test fire and explosion risk and the risk of thermal runaway. And these certifications are done by the underwriters' laboratories. There are also a couple of other certifications that deal with different types of battery chemistries and information that is good to know for specific deployment of battery installations. Next slide, please. Sorry, not next slide, just, yeah, perfect. So there's also the fire standard, the NFPA 855. So NFPA stands for National Fire Protection Association. This was created and adopted in 2020 and undergoes updates every 3 years. So the 2026 version just came out. It outlines design, installation, commissioning, operations, maintenance, and decommissioning battery installations. It also outlines maximum energy and then the necessary distance between packs and the integration of different fire equipment. One important aspect of the NFPA 855 is it mandates a communication between developers and local authorities, and so including the dissemination of hazard mitigation analysis, an emergency response plan, the safety system details, and then the results of that fire and explosion testing. So in Massachusetts, in our fire code, they've adopted the NFPA 1, which includes the NFPA 855. Next slide, please. I've mentioned thermal runaway before, so I just thought I'd give a quick overview of it. For lithium-ion chemistries, when the system malfunctions, there is a risk of overheating. And so this happens when a battery cell enters a self-heating state, and it can spread to nearby cells if it's not contained. Next slide, please. There have been a lot of improvements in thermal runaway prevention in the past decade or so. There's been thermal monitoring, which is used to detect temperature changes within the battery and automatically shut down batteries. There's fire suppression, which can cool those batteries before they reach temperature, the temperature threshold for thermal runaway. There's cell level monitoring, which can measure voltage and the temperature and the current of the cell and can also disconnect each battery cell. And then ventilation is a very important step to dissipate those gases that can accumulate during thermal runaway. And there are sensors that can detect the composition of those gases. And all of these things are automatic. And so, a good battery installation will have all of these different monitoring and suppression devices, and they're also mandated in a lot of the certifications and fire codes that we mentioned before. Next slide, please. The detection, prevention, and suppression methods have also really improved over the past decade. As I mentioned, NFPA 855 has mandated fire detection technologies. There's also spacing guidelines that, can mandate the maximum energy and also spacing guidelines. Fire barriers can protect racks from propagating to other racks. And then ventilation is really prioritized, which reduces the risk of explosion and thermal runaway. So batteries themselves don't explode, but if the proper mandated ventilation is not prioritized or isn't there, which again, it would be mandated under the NFPA 855 and the other battery certifications, those gases can then explode. But batteries themselves don't explode. Next slide, please. So what happens when a fire occurs? It is important to know that lithium-ion battery fires react differently than typical building fires. They do release gases that need to be ventilated, and then individual cells and modules are harder to get to with water and cooling agents than typical building fires. And they can reignite even if there isn't visible flame. Next slide, please. Battery fires can and have been successfully fought and extinguished with minimal harm. Water is still considered the best cooling agent for battery fires under the NFPA 855. There are some other cooling agents being tested, but water is still the one that is most widely recommended. The best strategy is often to first work on controlling the fire and then extinguishing, but controlling it first. And then for larger battery installations, water is used to contain the fire and cool the surrounding infrastructure, but is not directly used on the fire. And so minimizing the use of this water is important in reducing the risk of environmental contamination. And as we'll talk about a bit later, that risk is already very, very low. Next slide, please. It will depend heavily on the battery chemistry, the fire detection and suppression methods, and then also the layout of the facility, what firefighting strategies are used. And so that's why it's extremely important that developers work with local authorities and local firefighting stations to have the best sort of emergency response plan in place. Next, please. And so, yeah, training those local first responders and ensuring they're familiar with the facility battery chemistry and the firefighting methods is extremely important. And then the best practice is to engage as that development is happening. And with that, I will pass it on to Abby.
Great. And just to close this out, I'll also address some of the other environmental concerns that can come up with battery storage fires. Again, in the very rare event that there is a battery storage fire, as Ava mentioned, there are gases that are vented during a fire, which include things like CO2 and other VOCs, as well as hydrogen fluoride and hydrogen cyanide. These are, toxic gases that are released during sort of any sort of plastics fire. They do disperse very rapidly, and there have been air sampling that's been done around major battery fires in 16 states that found that those gases, because they're ventilated into the atmosphere so quickly, they don't pose an immediate threat to public health outside of the immediate vicinity of the fire. So even for homes that are nearby, because of the gases are being dispersed so quickly, there isn't that concern about the gases. They also don't pose an explosion risk if they're properly ventilated. And again, any good battery storage development should be designed with that ventilation in mind. That is part of the fire codes that Ava was talking about, is to ensure that those sorts of explosions don't happen. Next, please. And then again, in terms of water and soil contamination, good sort of firefighting practices for battery storage fires involve not directly applying water to the fire, which helps, again, minimize any sort of concerns around water runoff. Those sites should also be designed to minimize any sort of water runoff into nearby bodies of water. And also, even if there is any sort of water runoff, the chemicals that are created by lithium-ion battery fires have very low solubility in water. So again, there's not a huge concern of water or soil contamination. There have been extensive studies done after major battery storage fires, and the sampling that's been done around that, looking at the soil and water after BESS fire incidents, has not found any sort of high levels of hazardous contamination. Next slide. And I'm actually going to drop the study that I was referring to in the chat, just because I see some questions about it. And I think it is very helpful, a helpful resource. And I will say, again, you'll receive all these slides, and we include links to a lot of the studies that are referenced in the slides. So you'll have access to all these references. So again, with any battery storage installation, as long as it's installed following best practices, there's a really minimal safety risk. So that includes having those management systems in place to track both the performance and turning on all the installed cooling systems to prevent any sort of thermal runaway, early fire detection systems, including things like smoke detectors and air samplers, having all of those batteries enclosed in safe storage containers, so that there's also minimal risk of fire spreading to other batteries. And then a big thing is really just going to be making sure that there is coordination between the utilities and local first responders. So making sure the first responders are aware that there's a battery storage installation, and the best practices for fighting a battery storage fire. And we also will share resources. Clean Energy Group has several other webinars on how to safely fight a battery storage fire, specifically for first responders. So we'll share those later as well. So again, yeah, that training for first responders is going to be super important. Next slide. So again, some frequently asked questions. Can batteries explode? Again, the batteries themselves do not explode. It's a sort of caused by the buildup of gases. So properly venting those gases, which is required by fire safety standards, would avoid any sort of explosions. Battery storage fires can be fought with water. Again, for larger installations, they will use water to kind of cool surrounding areas and prevent the spread, but they will not be pouring water directly on the fire itself. You do not need to use any sort of PFAS to suppress it. Again, with like leaching chemicals, that's not a huge concern for us. With off-gassing, any gases are very quickly ventilated into the air, so there's not a public health risk there. In terms of their like noise pollution, batteries, there is some noise. There are mitigation techniques that can be applied. They are significantly quieter than like a peaker power plant. For any folks who live near those, I think, you probably have an understanding of how much louder a peaker power plant can be compared to a battery storage system. And then again, we did get some questions about if they can be built on capped landfills or on brownfields. Batteries themselves, just because there is a weight concern, typically can't be built directly on a capped landfill, but we have, there are projects in Massachusetts and elsewhere where solar is built on the landfill, and then the battery storage is sited next to the landfill to charge from the solar, but isn't directly on the landfill just because of the weight concern. So I think those are all of our slides. Yeah, so we do have some more resources that, again, you all will receive these slides with these links. So highly encourage folks to check that out. And with that, we would like to open it up for questions. So you're welcome to drop things in the chat. I see there's already folks that are dropping questions in the chat, so I'll try and go through as many of those as I can. But also I encourage you to just use the raise hand function. So if you go down to the bottom of your screen, you should see a raise hand option, and we can just call on you and you'll be able to unmute and say your question out loud as well. So in terms of questions, I'm trying to go through the chat. Let's see. Well, actually, one thing I did want to make sure we discuss, just because I know it's come up very recently, is sort of zoning and bylaws. So I wonder if any of our panelists would want to just discuss what's kind of the current status of local bylaws around battery storage and sort of the regulatory landscape around batteries in Massachusetts.
Hi, yes, there are a few municipalities that already have bylaws on the books. A lot of them deal with the amount of buffer space around a battery storage for different zones within the city. Right now, Massachusetts is drafting a model BSS bylaw, and it's really an interesting situation because the law that is promulgating these regulations says that all municipalities should adopt something similar to the state bylaws. If they choose not to adopt any, then that state bylaw will be a default. And right now that's under review. It's only a draft bylaw at this point, and the comment period for it just passed last week. They're going to finalize that bylaw, and then there'll be another review for public commenting before it's completely finalized. The ones that are on the books take a lot of different points of view. Some of them are really focused on protecting the environment and communities. Some are there to encourage implementation, so they're more incentive-based. Other ones are more safety-focused. Some have some provisions encouraging non-lithium batteries, and that's something that is becoming more and more common, is wanting to look at different technologies that are available. Some require internal heat sensors and monitoring systems. In Wilbraham, for instance, that's the local bylaw. That's something that is becoming a regular regulation at this point. Massachusetts is looking to adopt some of the national fire safety protocols in the BSS bylaws. So it's becoming more and more standardized, but it's all still in process at this point. And
Thanks, Rose.
I can drop a link to the reviews of bylaws that we did this summer in the chat.
Great. And then I do see some folks have their hands raised. So Michael De Chiara, and I'm going to butcher everyone's last name, so I'm apologies in advance. But yeah, you can go ahead and unmute.
Great. Thank you. And De Chiara, don't worry about it. I do have a question, but I might be wrong, but in terms of what Rosemary just said about the best draft bylaws, if a municipality does not adopt them, I don't think the DOER becomes the default. The regulations prevail. And so I think it's the regulations that prevail, not the draft bylaws. But my question, which so I'm in Shutesbury, small rural town. We've been dealing with this for years. And the two things I would point out, one is that the appeals court just confirmed a previous AG decision that battery energy storage systems are considered a protected zoning use, just like solar. So that's one of the constraints. But the issue that for small rural towns, we don't have water. And a lot of times when we hear these presentations, there's a presumption that there's municipal water systems that has adequate water. And so, you talked about using water for heat suppression and fire suppression, but if you have inadequate water, the best practice is to let it burn. So I wish, it'd be nice for you just to address that for situations where there is no municipal water, where there's just, pumper trucks that are insufficient for firefighting over days and hours. So if you can address that, I'd appreciate it.
Yeah, no, that's a great point. I think, well, yeah, I'm sure other folks are welcome to jump in as well. A couple of things. One, I think this is why it is so important for the utility or the developer to be in contact with local first responders. There should be existing fire suppression systems at the site that are addressing, cooling and thermal runaway before even the fire department is getting there. So that's one major consideration. And then the other would be, you know, again, working with local first responders to figure out sort of having a plan in place for if there is, if those fire suppression measures then fail, what are kind of next steps for either coordinating with larger departments to get more water or looking at other fire suppression methods. But yeah, I'd welcome thoughts from other folks as well.
Yeah, living in a similarly small town and seeing drought conditions most summers, you know, that's something that would be of concern to a lot of the rural areas. I think that's a case where when there's a project proposed, the municipality should require that there be water storage on site for any BSS that's proposed. That's the simple answer, hopefully.
I can also touch on, there was one study that found that a medium pressure water mist system was the most effective, and that will use significantly less water than a typical, you know, firefighting method. And then there are additional cooling agents that can be used. There are a handful of them. And there are more being tested for use, you know, when water isn't available. And I can, you know, put that study in the chat.
Yeah, and I'll just share because we're going to be sending a lot of resources. Our plan is to also send around a list of all the awesome questions we got with some of those links as well. So don't feel like you need to like capture everything in the next 15 minutes. But I just want to let folks know that we will try to get to all of your questions either now or in the email we send around afterwards. All right, getting to the next raised hand, I see Albert Musa.
Okay. In the beginning, you mentioned the $50 million program called AMP, state program. What does that program cover? And if you could put a link that describe it in detail, that'd be appreciated.
Yeah, so I'm happy to jump in, but other folks are welcome to as well. So that's the Advancing Massachusetts Power Program, I believe is the full name, the AMP. Yeah, great, thanks, Mary. And so there's kind of three different buckets that funding is going to. One is looking at alternative battery chemistries, so longer duration energy storage, and sort of those like the sodium ion and others that we briefly touched on. One is looking at community education and municipal education around battery storage. And then one is something that I forget. But I know there's three buckets. So yeah, if other folks remember what the third thing is, feel free to jump in. But I see the link is in the chat as well. Did that answer your question, Albert? And I'll move on to Monir Azam.
Hello. Yes, thank you, Abby, and great topic to cover. Really, a question on code consultants, and I don't know if there's a directory or a resource that you can offer for how to bring in the appropriate consultants or code experts that can help with battery deployments in various municipalities and jurisdictions, because it's that sometimes can be one of the big challenges. Yeah, thank you.
Part of the regulations that are being reviewed right now, part of that is grants for municipalities to hire experts. I don't know that there's a directory, and that's one of the things I suggested in our comments, is that there be some sort of help with people finding reliable consultants.
Yeah, I can echo what Rose said, and certainly as Beat was writing comments responding to those draft proposals, one of our pieces of feedback is that many small towns might never have encountered a piece of infrastructure proposal of this sort. So having references, having support to hire professionals, and having guides that give communities an indication of what questions they should ask about a given proposal, and understanding the technologies at play is really important.
All right. Lee Ann Ellis, is he next? Should be able to come off mute.
Yes, I am interested in the thought process of fighting fires or cooling other units with water. And I hear what you said, Rosemary, about having water containment. But from what I could see in the NFPA 855 dating to 2023, you have a sprinkler system that gives 0.06 or 0.03 gallons of water per square foot. Are you suggesting that water tanks are on top of the best unit and providing the sprinkler water for the sprinkler system? Or are you suggesting that there be a water tower or a container of water to fight the fires, to cool other units? Because, you know, I live in Beckett, and water, we're all on wells, and we're all on a medium aquifer, and water is, you know, a big deal for us. So how is this water containment going to be done? A, for the sprinkler, and B, to fight fires? Because these roads have to have 2 pumper trucks going up and down, right? So the roads have to be wide enough, which not always the case for 2 pumper trucks. Pumper trucks hold 3,000 gallons of water, you know, and yes, maybe you can get a mist, but not all municipalities have this kind of equipment. They have fire hoses, you know. So this is very curious to me. How are we supposed to do this?
My suggestion was that it would be the responsibility of the developer to come up with a fire suppression system. And if they're not able to, then that shouldn't be one that's built. If it's in a place where it poses a danger, that's a proposal that shouldn't be built. But you know, if they have a tank, it should be filled hopefully once and never used. Or during the one time that it is used, it probably wouldn't be used again. I mean, they might rebuild, who knows? But it would be a one-time fill. So those are the kinds of things that hopefully towns will have the ability to always review and use to decide whether or not something is appropriate to be built in a site where it's so hard to get that kind of supply. Hopefully towns could say no to that kind of situation.
And to build on what Rose just shared, I think that's an important point. With anything, any kind of energy infrastructure, siting is a really critical part of the equation. Any good idea can be a bad idea if put in the wrong place, right? And so we want to be really intentional about making sure that the siting is well thought out. And that's something that we're happy to chat with, you know, with developers about. If folks are considering a new, you know, a proposal in a community in Massachusetts, we're happy to chat about offering some suggestions, connecting with the community early on to see, you know, what their perspective is. Because we know we need batteries as part of this transition, as folks have been saying in the chat, you know, moving away from dangerous, polluting, unsafe fossil fuels that have, you know, their own whole set of problems. And so we know we need to move in this direction, and this is part of the grid that we need to be building, and how we go about that needs to be intentional to make sure that we're not just creating new problems or exacerbating existing ones by further impacting communities that are already overly impacted. So that's definitely something we want to be considering, and grounding those siting considerations in the science and the data and what has been shown to be, you know, what are the real parameters we need to be thinking about with these facilities, as you know, we've been pointing out with a lot of the resources we've been putting in the chat.
Great, thanks, Mary. I see, Donna, you mentioned that your question is sort of related to this discussion about siting. So, yeah, if you want to unmute and ask your question.
Hi, thanks. The audio button just appeared. So given your explanation was good about why the peak plants are the ones, we would rather avoid that, and they tend to be built in vulnerable communities and they cause a lot of air pollution and stuff. Is there a strategy statewide maybe to, when a peak plant needs to be decommissioned, that's a good site to put a BESS, or let's just go on and stop using them and put BESS in their place, or reuse the site that's already been used with something that pollutes less, or secondly, that batteries co-located with solar, like I can get how that's a good idea, right? They'll be ingesting the solar energy and then giving it back to us after dark. But if it's not at a solar and it's just, storing up whatever was on the grid and then putting that back, the benefits there for the clean energy transition are a little bit more tenuous, right? So could you talk about that as like an optimization plan across the state?
Yeah, it's a great question, Donna. There isn't necessarily a statewide strategy for that yet, but there are conversations that are underway. One space where that's happening is the Energy Transformation Advisory Board that the Healy administration set up, and one of the working groups in that under that advisory board is called Decarbonizing the Peak. And so that working group is specifically looking at case studies of fossil fuel peaker plants around the state and what kind of alternatives could replace those peaker plants. One of them is the West Springfield peaker plant that Rose mentioned that has already been decommissioned, and where the company is working to put battery storage in that, in place, because there is already that connection to the grid. And we're looking at other facilities as well, and examining, all different kinds of alternatives of what combination of technology could be an effective replacement for those facilities based on the site and the megawatts, of that facility. There are a lot of different factors that, the solution that works in one place isn't going to work exactly in another place. So really wanting to make sure that we're tailoring solutions to different sites and different facilities. But it is something that definitely is, people are aware of that being a smart thing to do, that when we retire these facilities, that's an easy place to connect batteries and solar. And I'll also point out, the Mount Tom coal plant. If folks in the Western Mass area were familiar with that, when that was decommissioned, solar was put in place there, connecting to the grid. So that kind of system, that transition, it has already been, that was years ago. So that's a pattern that already exists. Regarding the piece you said about, if they're not directly coupled with solar, yes, it's true that they, then they're just charging up on whatever power is on the grid when they're charging, but that still is better than if they weren't there, because then they're preventing peaker plants from being turned on. So when they're charging up, they're charging using whatever mix of energy on the grid, which is on the grid at that point, which could be some from a gas power plant, some from something else, but those are power plants that are running all the time anyway, and their emissions per unit of energy are lower than if a peaker plant were turned on for the 2 hours that battery could be discharging that power onto the grid.
Another plus too, this is true in the West Springfield case. They're using the existing interconnection, which saves millions of dollars on that project. That makes the cost of that electricity cheaper as well. It's a cheaper build out to go with the existing interconnections. We really advocate for replacing peakers wherever it's a good idea to put in battery storage, and also grid substations is another place where there are existing interconnections that can be taken advantage of. It saves a lot on building new infrastructure.
All right, I think we have time for one more question. For folks who are farther down the list, please put your questions in the chat and we will make sure to get to them in the email we send around afterwards. But yeah, I think Tom Seifert, you will be our last question asker of the evening.
Thanks very much, and thanks for a great presentation. I work in Wendell for the Planning Board and the Board of Health, and they are actively reviewing an application for a solar array with the BESS. The applicant might have to put into action a firefighting pond on site. The applicant will probably, is in training talks with the fire department about what to do, and they are considering supplying equipment because if an incident happened, most of the firefighting equipment would not be able to be used again, even the apparel. But another thing that has come up is in their incident action plan that is still being revised. It calls for an initial response from a minimum of 5 to 7 firefighting personnel. And in a town like Wendell, and it's kind of similar to the water capacity issues in other small towns, do you have a response to reactions to applicants where they are asking or indicating a need for more people power than is available realistically? Wendell might have just a couple of firefighters on a volunteer basis at any point in time, and to imagine having 5 to 7 or even more being at the site of an incident or a fire 24 hours for even a couple of days would deplete any response time to any other emergencies in the nearby area, et cetera. So I just didn't know if you had a response to the factor of how many people would be available to fight a fire in a small municipality, please.
I would imagine an automated system would be required. Again, this gets into community agreements and what the community would demand of the developer to make it reasonable, or to say this is unreasonable for us to sacrifice that manpower. Yeah, it really needs to be up to the developer to make it safe for the community. If the community doesn't have the resources, that probably shouldn't be built there.
Yeah, thanks, Rose. And I think that's maybe a good note to end on is, with all of this, we want to just make sure that we're sharing information to make these projects as safe as possible and to give communities, the knowledge they need to assess whether a project makes sense for them. So, as Murray said earlier on in our presentation, a good idea can be a bad idea in the wrong place. So, we're not saying that battery storage makes sense everywhere, but we are saying that there are many, many benefits to battery storage that, also need to be considered alongside the safety considerations. So with that, thank you all so much for joining us. We are going to get all the questions from the chat. So if we didn't get to you, I'm sorry, but we will send around answers to your questions afterwards, along with the slides and a recording of this webinar. So thank you all again for joining us. And please also, we'll share our contact information as well. So if there are additional questions or ways we can help your municipality or your community, please reach out to us as well. So thank you all very much and hope you all have a good evening.